Hello viewers, in today's class we are going to discuss an important definite integral involving greatest integer function, right? So here we have to solve this integral, and here this integral is given to be equal to square root of k plus m, and we have to find the value of k minus m, right? So here this expression, it implies that the value of this definite integral is or it must be this form, right? And we have to find the value of k and m, and then we can easily find out the value of k minus m, right, where k and m are some integers, right? So what we will do, will find out the value of this integral, and let us call this integral as I, right? So here we have the integral from -1 to -12, and greatest integer function, that is x square minus 2x minus 1 dx, right? So now we'll solve this integral. Now let us solve this integral by the method of substitution, right? So viewers, integration by substitution method is an important and powerful tool to solve integrals, right? So here let us substitute t is equal to x square minus 2x minus 1, right? So when t is equal to x square minus 2x minus 1, then we can differentiate both sides with respect to x. So dt over dx is 2x minus 2, and this is 2 times x minus 1, right? Okay, now here what we will do, we'll try to make a perfect square in x. So here we can write t as x square minus 2x plus 1 and minus 2, right? Now this term is a perfect square, so this is x minus 1 square minus 2. So therefore x minus 1 square is equal to t plus 2, and x minus 1 can be taken as square root of t plus 2, right? And here we can write square root of t plus 2. So this is 2 times square root of t plus 2, right? Because x minus 1 is equal to square root of t plus 2. So therefore here we can write dx as dt over 2 times square root of t plus 2, right? Okay, now let us change the limits accordingly, because we are changing the variable from x to t, and here we see that x varies from -1 to -12. So here when x is -1, then the value of t is equal to -1 square, then we have -2 minus 1 minus 1, so this is 1 plus 2 minus 1, so this is 2, right? And when x is minus half, t is equal to minus half square minus 2 times minus half minus 1, so this is 1 over 4, and this is plus 2 and 2 get cancelled, so we have 1 minus 1, so here we have 1 over 4, right? So now here when x varies from -1 to -12, t varies from 2 to 1 over 4, right? So now this integral I can be written as we have here 2, and then we have here 1 over 4, and for greatest integer x square minus 2x minus 1, we can write greatest integer t, and here for dx we can write dt over 2 times square root of t plus 2, right? And if we interchange the limits, then we can write this integral as taking this to outside the integral. We have minus 1 over 2, and we can write 1 over 4 to 2, and we have greatest integer t. Here we have dt, and in the denominator we have square root of t plus 2, right? So now we have to solve this integral. So now viewers, here we see that the value of t, it varies from 1 over 4 to 2, right? So here we can take 0, here we can take 1, and here we can take 2, right? And we see that the lower limit, which is 1 over 4, it lies somewhere here, right? So here we have 1 over 4, right? And this is the lower limit, and this 2 is the upper limit, right? So this is the upper limit. Now we have to integrate from 1 over 4 to 2, and we see that between 1 over 4 and 2 we have the integer 1, right? So 1 lies between 1 over 4 and 2. So what we will do, we'll split this integral as a sum of two integrals. So the first one is from 1 over 4 to 1, and the second one is from 1 to 2, right? So now I can be written as minus half, and we have two integrals, that is I1 and I2, right? So I1 is from we can write it from 1 over 4 to 1, and we have greatest integer t over square root of t plus 2 dt, and I2 is from 1 to 2, right? From 1 to 2, and here we have greatest integer t and square root of t plus 2, and here we have dt, right? So now we have two integrals, I1 and I2. I1 is from 1 over 4 to 1, and I2 is from 1 to 2. Now here we see that the value of t, it lies between, in the first integral, the value of t varies from 1 over 4 to 1, right? And in the second integral, the value of t, it varies from 1 to 2, right? So when t lies between 1 over 4 and 1, then obviously by the definition of greatest integer function, the value of greatest integer t is equal to 0, right? And when t lies between 1 and 2, then the value of greatest integer t is equal to 1, right? So now here we can write 0, and here we can write 1. So this integral is now 0 because the integrand becomes 0. So now I is equal to minus half, and this integral disappears. So here we have 0, and then we have 1 to 2, and here we have the value of greatest integer t as 1. So we have 1, and then here we have square root of t plus 2, and here we have dt, right? So now I can be written as minus half, and we have 1 to 2 and t plus 2 raised to minus half, and here we have dt, right? Now we have to solve this simple integral, and here we can again use the method of substitution, right? So we can take y is equal to t plus 2. So this implies that dy is equal to dt, right? And if we change the limits, then when t is 1, then y is 1 plus 2, that is 3, right? And when t is 2, here t is 2, then y is 2 plus 2, 4, right? So when t varies from 1 to 2, y varies from 3 to 4, so this integral I can be written as minus half, and we have 3 to 4, and here we have y for t plus 2, y raised to minus half, here we have dy, right? So now we have minus half, and the integral of y raised to minus half is y raised to minus half plus 1. Here we have minus half plus 1. We have 3 to 4, and we have minus half. Here we have y raised to half. Here we have half, and the limits are from 3 to 4, and this half get cancelled, and now I is equal to minus square root of y, and the limits are from 3 to 4, right? So now we can substitute the limits. So we have square root of 4 minus square root of 3, right? So now here we have I is equal to minus the square root of 4 is 2, and here we have square root of 3, and I can be written as square root of 3 minus 2, right? So viewers, the value of this integral is equal to square root of 3 minus 2, which can also be written as square root of 3 plus minus 2, right? And in the given problem, we are given the value of this integral as square root of k plus m, right? And now if we compare these two expressions, right, these two expressions, because here we have square root of 3 plus minus 2, so we get k is equal to 3 and m is equal to minus 2, right? And we have to find the value of k minus m. So k is 3 and m is minus 2, so we have 3 plus 2, that is 5, right? So viewers, the value of k minus m is equal to 5, and this is how we solve this important and interesting problem.